To solve number of smooth descent periods of a stock. This question has been asked in Google, Microsoft, Amazon, but this question is a part of the series two pointer or the questions that can be solved using subarrays, right? So in this series I'm going to be more focused on the two pointer approach, a question if it can be solved using a two pointer approach, or if the question shows a demand for a subarray and how we can solve it, right? So without any further delay, I'll just go through the question. So the question says you are given an integer array prices representing the daily price history of a stock, where prices I is the stock price on the ith day, right? Nothing new in that. You have a prices array, and each price here, each element here represents a price of the stock on the ith day, right? On the 0th day, first day, second day, like that. You have to find the number of smooth descents, right? So what is a smooth descent period? A smooth descent period of a stock consists of one or more contiguous days. So if there are elements like 3 to 1 4, so it could be a subarray of one or more contiguous day. That means one after the other, right? Contiguous day, such that the price on each day is lower than the price on the preceding day by exactly one, such that the price on the previous day is lower by exactly one, preceding day by exactly one, right? So if the days are 3 and 2, this is one day, this is another day, and if you see this element is less than the preceding element by one, so these two are also one more day. So now how many number of smooth descent periods are here? So 3 is 1, 2 is 1, and 3 2 is 1, so answer will be 3, right? So you want to return the smooth descent period, the first day of the period is exempted from this rule. So the first day is exempted, so first day is basically included in the answer, right? So for example 3 to 1 4, so here first day is exempted, so let's start with the 2. Already 1 we have, so 2 and 3 follows the constraint here, so they form a smooth descent period. 2 also is a smooth descent period, so let me just write how many descent period is here. So 3 2 1 4, then 3 2 is 1, then 2 1 is 1, and then 3 2 1 is 1. So how many there? 1 2 3 4 5 6 7. Answer is 7, right? But the main question is, let's say that I wanted to find how many subarrays can be formed for this length, right? So one of the formula for finding subarrays is n into n plus 1 by 2, right? So here n is the length of the subarray, but in our case, what will n be? N will be the length of a valid subarray. What is a valid subarray? A valid subarray is a subarray which follows this rule, that the preceding day by exactly one rule, right? So if I think about these three, it would be 3 into 3 plus 1 by 2, that is n into n plus 1 by 2, right? So it would be 3 into 4 by 2, which would be 6, right? And 4 anyway, a single number also represents the condition, so 6 plus 1 is equal to 7, right? So yeah, I can use the formula, but let me just tell you that this formula can also be written in a way as a form of number line, which will help you to understand how this formula comes, right? So ideally when I want to find the subarray, right, so what I will do is, whatever number I have, I'll just keep on adding it with the previous sum also. So this would be 3 plus, and this would be 2 plus 3, right? Something like this, so the final answer I get would be equal to the formula n into n plus 1 by 2, right? So here 1 plus 2 plus 3 is equal to 6, and that also, like 3 into 4 by 2 was also 6, right? So this tells us something, right? So how can I represent this summation? How can I represent this summation in terms of code? In terms of a code, right? So that's what I'm going to do. So I have another example for you, which is 5432. So basically what I did was I counted the running sum of all the numbers, all the valid L here, right? So here if you see, 5432 follows the principle of a smooth descent, right? Because 4 is less than 1 of its preceding element, 3 is less than 1 of the preceding element, 2 is again less than 1 of the preceding element, 3, right? So if I form which is in the formula, so 4 into 4 plus 1 is 5 by 2, 2 cancel, is answer is 10, right? Okay, now how can I form it? So I'm at 5, my current would be 1, and my total will initially be 1, because the rule says uh, the first day of the period is exempted from this rule. That means it is already included, right? So C is equal to 1, total is equal to 1, and I am at 5, right? Now I am at 4. This satisfies the rule, so I'll just increment my C to 2, but I want to keep on adding it to the target, right? So it would be 2 plus 1 equal to 3, which is here, right? How? Because if you see this, so I can, if I am assuming these two number, what are the combinations it can form of the subarray? It can be 4, it can be 5 and 4, right? Which is here. So if you see here, the total is 1 to 3, right? 1 2 3. So one combination, then two combination, 1 plus 2 is equal to 3. Okay, now compare, taking these three elements as a collection for this combination, I can form a subarray with 3, I can form a subarray with 4 and 3, because there's a if I decrease it with the preceding element, it will result in 1. Also I can form it with 5 4 3, because also it also satisfies the condition, right? So now how many combinations I can form? With the previous 5 1, then this 2 3, then this 3 6, answer will now be 6, right? Now taking these 4 as example, same approach. One combination, one subarray is 2, then another is 3 2, then 4 3 2, and then 5 4 3 2. The target would become 10, because 6 plus 4 is 10, right? So this is the diagram that explains this pattern very clearly. What essentially I'm doing is I'm just incrementing the count whenever the condition satisfies, and I am adding it to the total. I am keep on iterating over the total, because I want to create a subarray, right? So total plus current. Okay, now what the catch here is, suppose there is an element which doesn't satisfies the condition, right? Then I want to reset it. I want to reset my count. So what I will do is, if it doesn't satisfies the condition, I'll just have an else, where I'll just set the current to 1. So again from here it will try to iterate if the condition satisfies, right? So 9 8 might satisfies the condition from here, right? So I'll try to look for that, right? Okay. So that's the explanation for the question. Basically, whenever there is a subarray question, number of subarray for a valid length, the formula is L into L plus 1 by 2, where L is the valid length, or N into N plus 1 by 2, which I have said before. The way of writing it would be, keep on incrementing the count and keep on adding it to the total, right? So it basically tries to combine all the subarrays that we have been gone through, right? That we have been passed through. Okay, so showing you the code now. The code would something look like that. I'll have two counters, two variables, total and the current count, that is initialized to 1. If condition is satisfied, the condition is basically, or also I will start, okay, I'll just write it. So t is equal to 1, c is equal to 1. I loop from 1 to n, right? I'll first check if the current number, let's say the current is equal to the previous number, minus 1, right? So I'll just increment my C++, right, the current count, else I'll set it to 1 again, and my total, my answer, my result will be total plus C, which will keep on the count of number of subarrays, right? So this is the answer for this question, and I'll just return T, right? Okay, so this is what the answer will be. Also, if you try to compare it with the n to n plus 1 formula, which was resulting in 10, you will see that the approach will also result in 10, just for confirmation, right? So if you see this pattern, it's a clear hint to use something like this, right? Something like this. So going to the observation here, so formula for subarray with length n is n into n plus 1 by 2. Another way for valid consecutive number, or for finding a valid consecutive subarray, is this current increment and then target equal to target plus current. If it is a valid scenario, if it is an invalid scenario, we'll just do current equal to 1. Yeah. So that's it for today. Hope you understood the question. If you have any doubt, feel free to comment down. I'll try to explain it further.